Imagine you are sitting in a cabin of a 250 kilograms metal giant, descending through a wall of storm clouds. Outside, the rain is so thick it looks like solid glass. As the wheels reach for the runway at 250 km/h, something terrifying is waiting for them. It's called hydroplaning. With just 3 millimeters of standing water, the laws of friction change. The tires no longer touch the asphalt. They begin to surf on a thin film of water. In this moment, the aircraft is no longer a plane or a car. It's a high-speed boat with no rudder. The brakes are useless, and the runway is running out fast. The engineering counter-attack. But aviation doesn't rely on luck. It relies on physics. As the weight of the aircraft settles, the pilot pulls the reverse thrust levers. This is a mechanical masterpiece. Inside the massive engines, heavy metal doors, known as translating cowls, slide back. They block the exit of the bypass air and force it forward. Think about that. A machine designed to push forward at the speed of sound is suddenly fighting against itself. This massive wall of air acts like an invisible anchor, slowing the giant down when the tires cannot. You feel that deep, guttural roar and the violent vibration in your seat. That is the sound of 50.000 pounds of thrust saving your life. The synergy of systems. But the engines don't work alone. On top of the wings, the spoilers, or lift dumpers, deploy fully. Their job isn't just to slow the plane down with air resistance. Their primary goal is to kill the lift. By destroying the airflow over the wings, they force the full weight of the aircraft down onto the landing gear. This heavy press is what finally breaks the surface tension of the water, forcing the tires through the liquid film and back into contact with the solid ground. It is a perfectly timed symphony between the wings, the engines, and the rubber. The pilot's razor edge. Operating these systems requires surgical precision. If a pilot applies reverse thrust too late, the plane could overshoot. If they apply it too aggressively on a crosswind runway, the reverse air could actually push the tail sideways, causing the plane to skid off the track. Every rainy landing you've ever experienced was a high-stakes calculation. Engineers have calculated these margins to a 0.01% degree of accuracy to ensure that even in the worst typhoons, the aircraft stays where it belongs, on the center line. The conclusion. Next time you look out the window and see the engine cowling open up after a wet landing, remember the invisible battle that just took place. It's a victory of human intelligence over the chaotic forces of nature. Aviation is a world where we don't just accept limits, we engineer our way through them. Have you ever experienced a hard landing during a storm? Now you know exactly what was happening behind the scenes. Let us know your stories in the comments below.